Hello, everyone, and welcome to the Python hacking class where you will learn to build custom hacking tools. So, my name is Alex Thomas. I have been a penetration tester for about 3 years now. I mainly pen test Fortune 500 companies. I've been doing that for the company Bishop Fox for about 6 months. I am a recent college graduate. I graduated 6 months ago from Dakota State University, and that is where I got my bachelor's degree in cyber operations, and I also got my master's degree in information assurance. Some of my hobbies include robotics, machine learning. I also like to play CTFs, and recently I have been into game development. So, in this course, we will be learning how to create hacking tools using Python. First, we will start off by learning how to create a simple web scraper. Um, this is the basics of hacking tools. Basically, if you can create a web scraper, you can mimic any tool that is online. Um, we will be utilizing these techniques to create a proxy scraper, which is really useful. A lot of the times when you go to get a when you go to get some sort of proxy list online, they will try to charge you like 200 bucks a month. Um, but if you build your own tool, um, you can get a proxy list for free. Um, the second thing is we will build a vulnerability scanner. This will focus on detecting clickjacking in a website. So it isn't like a whole Nessus scan. We're only scanning for one vulnerability. Um, but it will teach you the basics of that. And then after that, we will build a basic port scanner. This will be similar to Nmap. We will be using socket programming. This is really useful to learn, not only for port scanners, but also for malware and stuff. If you want to create your own malware, you will be using socket programming for your communication. Um, and then we will wrap up with a password sniffer. Um, Basically, we will use SCAPY to create a password sniffer that can sniff HTTP passwords. Um, in order for that to work in the real world, you would have to do some sort of man in the middle attack. So, like ARP spoofing, rogue access point, something like that. And then you could run the password sniffing script in order to steal users' credentials whenever they log into a HTTP site. So that's it. I hope to see you guys in the class, and I look forward to teaching you guys. Thank you. Hey guys, in this video we will be creating a web scraper to scrape proxies from a website. So if we just go to Google, we can just type in free proxy to try to find some proxies that websites will have for us. So on the first link here, we can scroll down, we can see that it has a list of proxies. We can see that these are checked fairly often. This was checked 6 seconds ago, minute. This is just a table, just holds the IP port, the country, if it's an elite proxy, transparent, if it works on Google, etc. So basically we are going to create a web scraper to scrape all of these so that we can have a tool for this, um, so that we don't have to keep on going out to different websites and trying to scrape proxies. We can just run a tool to do it for us. So in order to do this, we will need two Python libraries, request and beautiful soup, and we can see the documentation. Not sure why that said that. We can see the documentation, but for some reason I cannot click on it. Huh. So if we go here, we can see the documentation and Python, beautiful soup. We can see the documentation for that as well. So I would recommend that you look at this documentation as well to get an idea of these libraries. So basically that's all we need. We just need to know how to use request and beautiful soup. With that and 20 lines of Python, we can create a proxy scraper. So first, let's create a file. Just name it proxy.py, and I'll use vim to edit this file. If you've never used vim before, it's just a text editor. I'm on Kali. There are other text editors like LeafPad right here. It's a little bit easier to use, but I'll be using vim. So if you type I, that will put you into insert mode, and then you can type stuff. Typing escape puts you into this non-interactive mode, and you can save your stuff by typing :wquit, which means write quit. That's basically the only two commands that you need to know if you are going to be using vim. So press I to go back to interactive mode. You can see right there. And first I need to first I need to actually install the Python libraries. You can do that by doing app-get install python-request, and I already have it installed, and we can install the second one in the same request, app-get install python-bs4, and that will install beautiful soup. So once you have both of those installed, now we can create our 20-line Python script. So go back in here, press I for interactive mode, and then type import request. And on the next line, we want to type in from bs4 imports beautiful soup. And I'm pretty sure something there is supposed to be capitalized, and it is the S. So now basically we can specify where we are getting our proxies from. We're getting it from this domain. So you can just copy that, and we're just going to create a variable, and we'll just call it proxy domain. And we will set that equal to that proxy domain. And next, we will need to reach out to this website and pull back the HTML source. And we will be using the request library to do that. We can do python-get, which will send a get request to this proxy domain. And we're going to save that into R, a variable called R. And if we just print that, we will see the source code of this page if I typed it correctly. And yes, so there is the source code. If you don't know what the source code is, it's basically the same thing as going here, right click, hit view page source. It's all of this stuff right here. And that will hold our proxies. So basically this is the HTML source, and we're going to be trying to scrape out this stuff right there. So now that we have the HTML source, and we got that using the request library, just sending a get request, now we can use Beautiful Soup to actually parse that HTML. So we can do soup equals, always misspell beautiful, beautiful soup, and then we want the HTML, r.content to get the HTML source, and then we just have to tell Beautiful Soup that we are an HTML parser. Cool, so now that we have that, we can actually parse this. So to do that, I will be just grabbing everything that's inside of this table right here. So in order to do that, we can inspect elements right there, and make sure you right click like where you want to inspect at. So if I click that, it'll take me exactly to that spot. So I know that this is a th tag for a table header. This is just some HTML. So this is the table, and if we highlight over that, it will highlight the table for us so we know exactly what is in there. So what we want is the tag, which is the table tag, and then we want the ID, which is proxy list table. And with that, we can parse out that table from the HTML source code. So let's go ahead and do that. We can create a variable called table, and we can use the find method. So soup.find, and we can give it a tag. This will be table, which you know we got from right there because it's a table tag. If we were parsing something else, it would be another tag. And then to narrow this down a little bit, we are going to include the unique ID right there. proxy list table. So that will only grab the table that has the ID proxy list table. To do that, we can create a dictionary, proxy list table. And to make sure that this works, we can try to print this, print table.get underscore content, or text actually. Sometimes I get some of these libraries confused with each other. So Python proxy.py, see if this works. And it does. So we see we have all this information that is inside that table. You see like our proxies, this is the stuff that we want to parse out right there. And from that, we then need to parse further down. So if you're familiar with HTML, you know that a table contains table rows, and then the table rows contain columns. And in HTML, a row is called the tr tag, and a column is the td tag. So basically we can parse out all of those tags, and you'll see exactly what I mean in a second. So from here, basically what we do is we create a for loop. So for row in table dot not get text, table dot find, and then I said that tr stands for table row, and we are actually going to change this to a find all, because the find will only return one instance, and the find all will return all instances. And just to make sure that this is working, I'm going to print this. So print row. And I messed up. And it's because I did not add that at the end. Definitely bound to mess up a couple times during this. Cool. So we see that that worked. It is printing all of the table rows that are located in that table. So next, we just need to narrow this down a little bit more to get the columns that are inside of each table row. And that's pretty easy as well. Just create a variable called columns. This will hold a list of stuff. And we can do row dot find all. And remember, I said in HTML the columns are a TD tag for a table description. So now this will grab all of the columns that are inside each row. And we can go ahead and print this. I'm going to put it in a try statement because I've already ran this before, and I know that some of the columns are blank and then it ends up erroring out and stuff. So we're going to put this in a try statement, try accept, and put a pass there to just continue going. This is so that the script doesn't error out. So now we can print our columns, and if we see here, I can just do columns Then I'm just going to grab the first column, whatever that is, and then dot get underscore text, and let's see if that works. Cool. So that's grabbing the first IP, all of this stuff in each column, but we also need the port as well, which means we need the second column in there as well. So in order to do that, this is just back to beginning Python stuff. It's going to go here. Then columns, we want the second column because we know that the second column is the port. Then we can print that. And here we have it. We have a Python script that can scrape proxies from a website. And if you're looking here, this is scraping a lot of proxies off that website. So we can get even more information. Basically, we're just grabbing the IP and the port right now. We can get the country, the anonymity with it, if it's HTTPS or HTTP. We can get some other information with that as well, just by adding in some more columns right here. So I'll go ahead and do that. Let's make this look nice, put a tab, add another one, a tab. Then I'll do columns 3 for the country, get text, and I'll do columns, forget what it is, 0, 1, 2, 3, 4. Why can't I go up? Goodness. And 4 dot get text. So that should print everything that I want to print to make it look nice. Now I can just write and quit, run the program again. And I obviously did something bad. Which I did. Printing 4 things, but only have 4 substitution. There, that should work now. Awesome. So that looks a lot better. A little bit. It actually, let me add one more. Trying to get this spacing so it's not super ugly. No. Nah, that's a little bit better. Whatever. So basically there you have it. You can get the spacing to look better just by, haven't done this in a while. I think you just do like -40 or something. You guys are seeing live coding here. Pretty sure you could do -40 and then that'll adjust the spacing in Python, if I recall correctly. I could be wrong. Okay, cool. That's too much spacing though. Man. And there we have it. That looks a little bit better, whatever. But we see we have our script. It's pulling down the proxies. We can get the country and if it's anonymous, elite, or transparent. So that's it. You can scrape from other websites as well. You could keep adding on to this tool to get like 50 different websites, and then you would be able to scrape thousands and thousands of different proxies within a given second. So you can definitely add to this. There are also easier ways to make this. For instance, maybe I could have created a regex to just look at the source code and then just find proxies that way without actually parsing everything. So that's it. Stay tuned for the next video. Hey guys, in this video I will be teaching you how to create a Python script to identify the clickjacking vulnerability. If you don't know what that is, basically it allows you to load a external website in a iframe, and then you can trick users into clicking on that iframe, um, which will allow you to do things such as forcing them to donate money by clicking a button. You can change their email address and stuff. Um, so there's a website out there that allows you to scan websites to identify that vulnerability. It also scans for other security headers, which I will talk about a little bit, but I am going to mainly focus on the header that is associated with clickjacking. So there's a website that allows you to hack them. Let's hack this site, I think. Yes. So I can scan them legally. I'm going to use this site as an example. So we see that this website identifies that it has 2 security headers, but it's missing 5. We see that the X-frame options header, that is the header that is associated with clickjacking. And if that is missing, then they are vulnerable to clickjacking. I guess I could talk about these other headers for a second. So this, the strict transport security header, basically is saying you have to use HTTPS. That is there to help prevent people from using HTTP, which we all know is insecure. The X content type options helps prevent against sniffing of meme types. And then you have the content security policy, XSS protection, protection against XSS, and these other two. So we're going to focus on the X-frame options, and we will be building a tool that's just like this website that can scan that for us. So before I actually, let me just go to, if you've never heard of HackerOne, it is a bug bounty website, and they have a bunch of clickjacking reports if you want to read other people's findings. This first one I thought was really weird because it was a clickjacking report, but they got paid $5,000, which I thought was super high. I haven't actually read it, so there may be more to it than just a simple clickjacking. And then there's some other ones, like this one. So you can read these and see what they're doing. We see here that due to missing X-frame options. That's the same as that right there. So what we're going to do is create a Python script to check for that header so that we can automate some stuff. So let me create a file called clickjack.py, and then I like to use Vim. You can use whatever editor you want to use. Type I for inserts, and then now we can type. So I guess actually I'm going to show you this in the Python interpreter. We can just get to that just by typing Python. And then we're going to use the request library. If you didn't download that in the other video, you can do that by doing app-get install python-request and then hit enter. I already have it installed, so I'm not. After that, and then we can import the request library, but just by typing in import request. And basically what I'm going to do is I'm going to reach out to this website, and I'm going to get the headers that it is using. Don't like how that looks. So I can do that just by creating a variable, set that, actually just gotta print this in just one line. And request.get, send a GET request to this URL. And then let's get the headers by typing in .headers. So we see here these are the headers that it is using. And we see the strict transport security and the X content type options. And those are the two that it says that it did have on this other website that we scanned it with. And we notice that it's missing all of these. We can verify that it's missing the X-frames options just by looking and seeing that there is no X-frames options there. So that's really easy to find. We just have to take this and just look for that header, and if it's missing, then the website is vulnerable. So same thing, import request, and then let's just create a variable called headers and set that equal to the same thing, request.get actually create a variable called domain real quick. .get domain, and this should print out the same thing. Just got to run it real quick just to verify. And I messed up on something. Did not put the dot headers at the end. No matter if it's 3 lines or 20 lines, I always end up messing up on something. Cool, so that printed out the same thing. Now we just need to look in that list, and then, or dictionary, and then we can search for the iframe header. So that's super easy to do. We just type if, then we're looking for this header, X frame options in headers. So that's just saying that if it finds this in the headers, then we can go ahead and just pass, and if it isn't in the headers, then we can just print some vulnerable. Cool. So this should print the domain name with the word vulnerable at the end. And we see there that it does. Awesome. So now if we just type in another website that I know isn't vulnerable, such as google.com, then it should print nothing. And I'm actually going to change this so that it does print something so we can actually see it. So let's check google.com. I'm pretty sure they're not vulnerable. And we see it prints back google.com not vulnerable. Awesome. So basically we can take this script, we can now scan a website to see if they are vulnerable to clickjacking. We can hop into the bug bounty world. We can submit some bug bounties pretty easily just by going on the HackerOne, checking some domains with this script, seeing if they're vulnerable. If you find one that is, then you can submit your bug bounty and possibly get some money from it. You can create this script better. Like I said, we're just checking for the X-frames options. We can check for all of these other security headers as well, just as easily. So instead of putting X-frames options here, we could change that to strict transport security, and then that would check for that header. Then we can just have a bunch of if statements that'll just check for each header. We can also scale this up a little bit. So instead of checking one domain at a time, we can maybe have a list of subdomains, or maybe we have a list of the top million domains. And then we can search on all of those and check which of the top million domains are vulnerable to clickjacking and which are not. You can do some cool research on that. Um, so you can definitely add a bunch of stuff to this, like, extremely small tool. Like, this is like 10 lines. So that's it. Just as a recap, we learned about clickjacking a little bit. If you don't really know what that is, I would go on YouTube, type in clickjacking, download some vulnerable app, and practice a little bit. It's pretty easy to exploit. Um, and then after clickjacking, we learned how to create a simple Python script to check for missing security headers. The clickjacking security header was associated with the X frame options header, and if that isn't in the response headers, then we know that the website is vulnerable to clickjacking. So that's it. Hey guys, in this video we will be talking about how to create a port scanner similar to Nmap. We will be using Python socket programming. So first, let's just use Nmap to scan a server that I have up so we can see what ports are open. So 102. Cool. So we see that Nmap just shows us a list of ports that are open. Awesome. So we can use Telnet to do a very similar thing to Nmap. Telnet just uses socket programming just as Nmap does. So if we do Telnet, then this the port at the end, we can tell that the port is open because we connected successfully. So if we do the same thing with a port that isn't open, we get this unable to connect. So that tells us that the port is closed. So we're going to take that similar concept to create a port scanner in Python. So if I create a file called port scan, and the first thing that we have to do is import the library socket, and that should be already installed. If it isn't, you will have to install that. Next, I'm just going to create a variable to hold the IP that we want to scan. Ideally, you would use command line arguments, but I'm trying to create this with as simple as possible. So we can just put the IP right there, and then to scan each port, similar to how we did it with Telnet, we have to connect to each port separately, which means we'd have to do something like 1, then 2, and then Telnet to port 3, 4, etc. So we can do that in Python just in a for loop. And we can do that by by 4, and then port in range, then just I'll do 1 to 100 just to get started. So basically this will loop through 1 through 100, and it'll save the number in the variable port. So port will be 1, then 2, then 3, then 4, etc. So then after that, we need to connect to the IP and port. And if the connection fails, we know that the port is closed, and if it doesn't fail, we know that the port is open. So we can do that in a try except statement. So we can try to connect, and if it errors out, we know that the port is closed. And the actual connection part will be done with the sockets library. And just for reference, you probably want to, go to Google, type Python sockets, and then find the documents for it. This isn't the actual documents, but just find some references so that you can get some examples and know the functions that are in this library. So what we're going to do is we are going to connect to create a socket first. This will be a IPv4 TCP socket, and normally you have to add in extra stuff in there. Let me see if I can find it right here. You would have to add in this part, socket.af inet, which stands for IPv4, and then you have socket.sockstream, which stands for TCP. So you could change this to something else if you want to scan for UDP, and change this to scan for IPv6. But we don't have to put that because when it's blank, it is implied that you are scanning IPv4 TCP. So that's awesome. Next, after that, we need to connect to the IP and ports. We can do that just by doing s.connect. Then pass in a list, and we will do the IP, comma, port. So we get the IP from right there, and the port is looping over this range. So we're going to try to connect to port 1 first, then port 2, then port 3. And at the end, we have to make sure that we close this connection. And then let's just, if we get down to all of this and it didn't error out, that means that we connected successfully and that the port is open. If it did error out, that means that the port is closed. So at the bottom of this try statement, we can go ahead and just print this right here, which will just print the ports that are open. So if I run this, and if I wrote this successfully, we should be able to scan our server, and it will just be just like a regular Nmap scan. Cool. So it sees that port 22 and port 80 are open. Before it showed a lot more ports. Might be asking why is that? Well, that's because we're only scanning 1 through 100. So let's change this to like 10,000. And that should bring up everything. Now this is much slower because we're not using threading or anything. We're scanning each port one at a time. If we were using threading, this could go much faster. So that was the output from our port scanner. And now if we just look at Nmap again, just to compare them, Nmap shows that the same ports are open. Nmap does have some additional information. For instance, it identifies port 22 as SSH. That could easily be done in this script as well. You could also add in banner grabbing, support for UDP, threading, a bunch of other stuff. This is just a basic port scanner. It's super small. You can create this in like 60 seconds to get a basic port scanner up and running. You can add on to this and make it something like Nmap. So that's it. Thanks. Hey guys, in this video we will be going over how to create a password sniffer using SCAPY. So this will be similar to sniffing passwords using Wireshark, but instead of using Wireshark, we are going to use Python. So first, if you are on Kali Linux, SCAPY is already installed, and if you are not on Kali, you will have to install it. If you go to Google, you just type in SCAPY Python, you can get to the documents about SCAPY. It says you can, shows you how to download it and stuff here. And then it just gives you the usage and stuff, just like any documentation and whatnot. So we will be using SCAPY to sniff passwords that are going over HTTP because it's unencrypted. SCAPY can do a lot of other things, such as creating fake access points. You can recreate Airmon NG. You can deauth people. You can create a ARP spoofing tool. You can create a bunch of tools using SCAPY. What we are creating is just the tip of the iceberg. So to get started, I'm going to create a file called sniffer. Then I will go in there, and then first we need to import SCAPY. And in order to do that, we type I to go into insert mode. We type from scapy.all import star. So import everything. After that, we can put SCAPY, we can tell it to sniff on a specific interface. by giving it this command, and then iFace will be equal to whatever interface you want to sniff on. In my case, it's eth0. And then you need to give it the function to call once it sniffs a packet. In this case, I'm just going to call that function sniffer. After that, we can filter certain packets. We can filter certain packets by doing this, and then I'm going to filter on TCP and port 80. So this is basically going to filter on the HTTP traffic. So now we have to create our function sniffer, and it will be getting passed a parameter. We're going to call it packet. So every time the sniffing function finds a packet that matches this filter, the packet will be sent to our sniffer function right here. Then basically, just gotta rename this. HTTP packet equals packets. And I'm just going to print this packet just to make sure that everything is working. Seems to be, let's just, if you go to Google and you type in HTTP login, you can get some test login that uses HTTP. So this is not a valid password. I'm just seeing if the Python script is picking this up. It looks like it is. You can see the username test and password T, which is what I typed in. So we know it's working so far. We just need to clean up the rest of that mess. Cool. So now, instead of printing the packet, we are going to check to make sure that it is a post request, because HTTP can have several different methods, such as get, head, options, and post, and then there's several more. So we're just going to make sure that it's a post request, which is the request that we want. So here, post, making sure that the word post is in this packet. And we will have to convert this to a string first. So if the word post is in the packet, let's go ahead and print that packet. And like always, let's go ahead and just run this, make sure everything is working okay. I'll type test and test. and we see we got some stuff here. We can see there's the post thing that we're filtering on. So it's post request to this post right here. Verify that that is correct. And here's some stuff that we don't really care about. And then everything below this is the data that is being sent. And in this case, it's sending our username of test and a password of test. So the stuff that we want to filter out is the host and our data. That's pretty much the only stuff that we care about in this case. So let's go ahead and do that. So in order to do that, I'm just going to do string splitting. And I know that, let me go back here. I know that at the end of each of these, it's being split by a /r/n. That's just common between the HTTP protocol. So it goes host, then the name /r/n, next line /r/n, till it gets all the way down here. And then it goes /r/n to go to this line, and then another /r/n to get to your data. So that's important to remember, and you'll see why here in 2 seconds. So when I'm filtering on this domain name, I said that I need to filter after the /r/n. So that's just gonna, so in order to do that, I'm going to use string splitting. And I'm just going to split up that whole blob on /r/n. And this will create an array. And I know that the line that I want is the second line. So because arrays start with 0, that will be the first index. And I can verify this to make sure that it is working correctly. And I should just see the host name. Which looks like I might have messed something up there. Let's see. I am not printing, that's why I don't see anything. So let me print the domain name, and then go back. And now we see the host. We have parsed that out of that blob here. So just for visual again, this would be the first line, and then it's a /r/n, second line, third line, till you get down here. So now I want to parse everything after that colon there, because I don't want that host part, I just want the name. So I'm going to go ahead and do that. And that's pretty simple. We're just going to use the split method again. And we can split on that and grab the everything after that. So the first index, not the 0th index. Test this real quick. So we were able to parse out the domain name. Now we just want to parse out our data. And we can do that basically in the same way. We will be using the split function to split after /r/n/r/n. So data equals string http packet dot split then /r/n/r/n, and everything after that will be our data that is being sent. So now let's just verify by printing that. And we see we get the data that we sent. Test and T for password. Cool. So now really the last step is to just make this look neat whenever it is printed out, so that you can just leave this running and then come back and look at it later and see all the stuff that you found. So I'm just going to print a bunch of asterisks. I'll print those 20 times. Do that again. Then in between those asterisks, I will print the domain and the data. Let's put a new line there. Cool. So now we have some nice output, nice looking output. Now we can go ahead and run this. And hit test ing. And we see here we were able to capture the credentials that were being sent. We have the domain and we have the password. So we can then log into these afterwards. And it'll just sit here capturing data until you turn it off. So basically, to use this, you would want to somehow get a victim's computer to send their traffic through yours. And that can be done in a number of different ways, such as ARP poisoning and rogue access points, a rogue DHCP server. There are a bunch of ways to do that. But then once you have that, you just simply run this script, and then if they log into a website that is using HTTP, you will be able to grab their credentials. And that's it. So as a quick recap, we just created a script using the SCAPY library. The SCAPY library can do a bunch of other network stuff. You can create hundreds and hundreds of different tools using this library. And we used it to create a HTTP password sniffer. And we can see here that it's like 10, 15 lines long, super small and short, and pretty powerful. So that's it. Thanks.